Don, Joe, welcome to Composites Weekly.
Yeah, thanks for having us.
Yeah, thanks for having us, Jonathan.
Yeah, why don't we get started by having each of you, Don, we'll start with you, maybe share a little bit about your background, and then Joe, if you'll follow up.
Okay, my name is Don Paquet. I've a PhD in chemical engineering. I've been doing the polymerization reaction engineering for about 40 years, worked for large corporations. I've worked for L&L Products in the last 9 years now, and my role is intermediate synthesis, so for materials.
Joe, how about yourself?
Yeah, so Joe Stanish, about 30 plus years in the composites industry, have founded and owned a couple composites companies, both in thermoplastic and the thermoset side of composites.
Okay.
Have a lot of experience in commercializing, both in sporting goods, industrial, and aerospace composites. So
Yeah.
all sorts of processes.
Yeah.
And yeah, just play with glue and string.
There you go. So you've been in both thermoset and thermoplastics. So with
Yes.
what is your preference? Do you obviously right now you're in thermoplastics.
Yeah. I think they both serve their strengths really well, and I don't think one is better than the other. And I think lately there's been a lot of work in combining the two. Like
yes, yeah. So you were talking, you just got back from the, I want to mention real quick, you just got back from the IACME members meeting up in Colorado. Give us your take on that, if you would, and your thoughts.
Yeah, fantastic. It's really a small focus group of individuals with a lot of different backgrounds. But for me, as a NASA nerd, the highlight on Wednesday was Carolyn Obermeyer, who's the lead engineer for the Origin spacecraft, gave a speech,
right,
and then talked about where composites can be better improved.
Yeah,
and so it was good for her to both for us to be the listeners of a great storyteller, and then two, to kind of understand some of the problems of the capsules and composite needs as an industry.
Yeah. Oh, for sure. I sorry I missed that. That sounds like a really interesting talk. I wish I'd had a chance to listen.
Yeah, it was definitely a highlight.
So yeah, let's get into the topic. I want to talk about the T-Link technology. We've got that actually highlighted up on the screen. If you're watching on our video section, let's start with, if you would, or Joe, I'll invite either one of you to chime in. Let's start with the foundation. What is T-Link, and what's one of the problems you're trying to solve with in developing this technology, this thermoplastic adhesive?
Yeah, so T-Link is a thermoplastic adhesive resin that we like to think has the adhesive properties of an epoxy thermoset, but it's a thermoplastic. And it's been developed over a few years as a film or yarn or pellet. And it just provides good bonding to really polar substrates. And so we had recently been working with it in ballistic applications, and our customers kind of wanted a thinner film. And so we had worked on improving the polymer to make it a little tougher so that we could robustly produce a thinner film. And we did that, and then we started to lay it up in composites, and that's when Joe took notice of what we had. So I'll defer to Joe.
Yeah.
I think Don can get a lot more into the background and development, the chemistry of it. But as a toughener, an interleaf toughener in thermosets, there's been a lot that's been done over decades without a lot of progression, you say. And looking through some of the initial data with Don and his team, what really stood out was the ability to enhance toughness in an inherently brittle material. Thermosets are incredibly strong, but they don't have the impact resistance that you have out of thermosets or thermoplastics rather.
Right.
So combining the two gave a unique opportunity to test the waters. And we did some work with NIAR to validate this after our own internal test labs with compression after impact. And Don, I think maybe you can quickly speak to the results that we saw in CAI testing.
Yeah, I think we saw like over a 60% improvement in compressive strength after impact. And even visually, if you look at the damage area, you'll see that with the interleaf in there, it was a significant reduction in the damage area at same energy.
Obviously, we're talking about an adhesive that you can be bonded, but also it's unlike a thermoset, the ability to debond.
Yeah, I would say, as long as the substrates have a higher TG,
yeah,
and probably much higher TG than the T-Link itself, it does give the ability to build replaceable panels. But I think, one of the biggest attributes, and we're still really discovering this, is what substrates we can bond together and what processes we'll need to use, either be it ultrasonic, what types of surface preps on dissimilar materials. So metallics and thermoplastics, thermoplastics to thermosets. And that's what Don and the team and myself with some guidance are kind of working to explore.
So in terms of structural performance, you were talking earlier, what is the any data on the long service life in terms of structural performance?
Well, we've done some fatigue data on the composites with and without the interleaf film, and the only thing I can say is there was no difference in the fatigue life.
Okay.
So we think it'll do okay.
Yeah. And what types of applications? I know there's different forms. I was reading on the website. I mean, you can get this in different forms for different applications. What are some of the industries that are most interested in this type of technology right now?
Aerospace and industrial. There's a constant desire to weld. We call it welding in thermoplastics. Dissimilar materials together, because polymers don't like to play outside of their own family. So nylons and bonds bond well together. Peaks bond to peaks. But if you have a dissimilar thermoplastic and you want to bond it, and this doesn't work for everything. I think we should be really clear about that, and we're developing the guidelines to what you can. But I think there's a lot of desire to bond thermosets to thermoplastics where I think we'll be well served. And so I think that's one. There's a lot of desire to bond stainless and titanium to thermosets and thermoplastics, and that's another area that we feel we'll be able to perform really well in.
Yeah. Any case? I know you've got a number of case studies that are highlighted on your website, and we'll try to direct our listeners to where they can find it on our show page. But anything that comes to mind, Joe, that you would like to talk about with any particular, you don't have to mention companies, but any specific applications that you guys have worked, this has been incorporated.
Yeah. There's a couple sporting goods programs that are going on right now that I can't speak to, that they're finding some real good success within interleafing as a toughener into a thermoset.
Yeah.
So that's one area. There's another area where, they're actually using this to stitch either a commingled or a toe preg onto the film. So you're getting that interleaf toughener or even surface toughener,
right,
instead of stitching into a veil. And so we have some programs going on in that space.
Is that where they you have the yarn? Is that the
Yeah.
Okay, cool. Because this comes in multiple forms. You've got pellets, films, yarns. Maybe you could
Yeah.
talk a little bit about each of those forms and what they're used in.
So the company I'm speaking about is Next Gen, where they're
Okay.
building preforms. So they're stitching toe pregs or commingled material onto a substrate.
Okay.
And so that's proven to have some early success. So we'll follow that.
Mm-hmm.
Yeah, there's a couple other projects on the aerospace side that I can't.
Yeah,
speak.
you can't.
But
but you're getting a lot of interest from the aerospace industry in this.
yeah, absolutely. Yeah, absolutely. And bonding thermosets to thermosets and thermosets to thermoplastics.
Yeah.
So,
are there any environmental? I know high heat can be problematic. Are there? And I'll send this over to you, Don. Any environmental limitations from this technology?
I'd say high heat may be an issue with it.
Yeah.
It does have some limitations. I think we've only done cursory testing in hot, humid conditions. So
Okay.
that's something that we're actually, under the guidance of Joe, we're starting to develop the test protocol to actually see how it performs. L&L is more of an automotive supplier, so
Sure.
we're stepping a little bit outside of our realm of expertise, and so that's why we kind of rely on Joe to give us some
Absolutely.
advice as to what to test.
Yeah. I was reading about the body armor. That kind of grabbed my attention. Maybe you could talk a little bit about that. It's being used in body armor systems.
Yeah, I'd say that the adhesive it works quite well with aramid fibers, and it's got the right consolidation temperature. I would say that it's been used quite a bit. So,
Yeah.
and in fact, that's kind of what drove our system, is that we were originally a little thick in our films, and so to control the amount of adhesive, they went to coating yarns, monofilament, commingled, and eventually thinner films, or even micro pellets where you can just dispense it to control the adhesive amount.
Okay. Yeah, I was going to ask it. What would on the body armor? What are they using? The pellets and then heating those, or
Primarily, it's been the film.
the film? Okay.
Yeah.
Well, that makes sense. Lay out the film because it's kind of a flat sheet, right?
Yep.
In between.
Yep.
Automotive. I know that's been your forte for the longest time. Automotive has been using structural adhesive for years. Are you getting interest? It sounds like this is an area of opportunity with your own customers and some of the partners that you're working with in that market as well.
For composites, well, actually T-Link has been a component of our structural epoxy foams. And that's where it originated.
Right.
So that's how we use it.
Yep.
I think now we're interacting with them in terms of using this as an adhesive filament for automotive applications.
What excites you right now most about this technology moving forward?
For me, this is kind of a fun thing that Joe seems to think this has a really good potential in composite applications. So it's like, okay, tell us what you think we should do, and we'll test it out. And
bring us the the applications, and we'll do some testing and see.
Yeah, what I find to be really exciting about this is just using the best attributes of a thermoset and forming complex curvatures and structures out of thermosets that are not as easy to do as they are in thermoplastic, and then taking thermoplastics where they're really good in flat sections and reinforcements and tying the two together.
Yeah.
So, and this we could talk about some of the bonding temperatures where the shear is best. Is kind of with a 350 cure system. So talk about taking a PEEK or a PEC or a PPS and bonding it to a 350 cure epoxy system. Don, you can explain like where we're getting our best shear properties and temperatures at.
Yeah, it is right around 350 is where we actually start to get really really good results. So
Mm-hmm.
And then we're seeing somewhere north of 20 on the megapascal on
yeah,
moisture.
yeah,
Right.
yeah.
So that's really, if you talk about that compared to traditional DP systems from 3M, two-part epoxies, you're getting a much better mechanical bond.
What are the temps for reverse bonding? What is that?
That's a good question. I think we've done some reverse bonding at about 400F.
Okay.
So
It's a thermoplastic, so
yeah,
it's that
Yeah.
the T sub G in a thermoplastic
Yeah.
is different than the
yeah.
T sub G in a epoxy system.
Yeah. I guess what kind of questions are a lot of the OEMs asking you all, or what they're trying to solve?
Well, it's in two different fronts, I would say, as a interlaminar toughener,
Mm-hmm.
and that's pretty niche. But I think the bigger is just the ability to bond to similar materials together,
Yeah.
with a better, more controlled system. With a two-part epoxy, you've got to mix it. You've got
Yeah.
you've got your pot life, and you have your different spreading mechanisms, and then post cure, where this may be something that you can co-cure onto a thermoset surface and then come back in with your other substrate and apply pressure and temperature to it.
Yeah.
So this would lend itself really well to um, various forms of induction welding,
Mm-hmm. Yeah.
which are pretty advanced, and probably closer in reality right now would be just ultrasonic. So
Oh, interesting.
yeah.
Yeah. And I'd say the nice part, it's a dry to touch film. It doesn't need refrigerated storage. It can just keep it out of sunlight and be about it. So.
And as you were saying, Joe, it's not you don't need a two-part. I mean, this thing just, there's no chemical. It's just cooling. What is typical the cool time or the cure time look like on this?
Well, it's a thermoplastic, so basically you just have to cool it down.
Yeah.
Probably to less than, say, 140 F, and then it's done. So you heat it up. Yeah, that's it.
Yeah.
Yeah. But if you're using this in an application of ultrasonic, as you're rotating, you can trail with a cooling shoe as well. So you could do this in a continuous process. You could do this in a spot weld process where you come down and you hold and you cool down.
Right.
But the advantages with thermoplastics that I've seen in my career is just the ability to go through multiple thermal cycles and go through them quick.
Sure.
Besides the heavy crystalline structures where you want to take your time in your cooling rate, everything else is as quick as you can cool it.
Yeah.
I think it's worth mentioning that this is an amorphous polymer, so there's no crystallinity to worry about. This is just a great overall adhesive that works within a desired temperature range.
Yeah.
So,
what any unique applications you've been involved with that you've had requests over, or that you've looked at specifically?
yes.
You don't have to mention companies or anything.
Yeah. A couple that all I can say is, like, there is the ability with the monofilament to actually commingle into different yarns. So I would say that's one that's pretty niche right now.
Yeah.
I can't tell you what the application is, but that one's fairly exciting in its possibilities.
Sure. So great. Well, guys, thank you. I appreciate you both joining me today. It's fascinating technology. What if people are interested in learning more? We'll obviously be highlighting the LNL or the link where they can learn more directly to the T-Link technology. And if they have questions, they can reach out to you. If you don't, if either of you, especially you, Joe, maybe I can put your LinkedIn at least where they can connect with you if they have questions or would like to explore other, opportunities related to this. They can reach out to you.
Sounds great.
But and last question for you, Joe. I know you're, as far as thermoplastics in general, what excites you most? I know you were out at the IACME and just looking ahead with all of the developments in aerospace and space applications. What's one of the things that excites you most about thermoplastics in general?
Well, I think if you look at the Clean Sky project, it was a multi-company, multinational effort. Just the demonstrator of that level of structure and the different welding technologies is always exciting to me. So I think on the thermoplastic side, that's probably some of the more exciting things. I've done a lot of design in impact areas and vibration damping within sporting goods, with fiber reinforced thermoplastics. And I always find that fascinating where, thermosets they're stiff. They're everything you want in some aspects of performance, but, the ability to decrease, harmful vibrations transmitted through your hands and your feet are always something to me that is fascinating about thermoplastics as well.
Yeah, as a tennis player, I mean, I definitely know all about that.
I think we've all felt it.
I can't relate to some of the guys that are pro players that are serving at some of the speeds they're doing. But I can tell you when you take a return on and you feel that shock and that goes up into your wrist and arm, man, that is
And I think there's still a lot of work to be done in that area to improve sporting goods products.
Yeah, absolutely. Well, guys, thank you both for joining me on the podcast. Looking forward to getting this out. And I do want to mention the website. Again, is tlink.llproducts.com. Again, we'll be posting that on our show page for this episode. And once we post it out on socials next week. And I assume you guys will be at CAMX in September.
We'll have a booth.
Well, I will certainly stop by and visit with you guys there. Hopefully we can have you at our location for maybe a live interview during the show.
That'd be great.
Sure.
Yeah, you can bring some products and some samples by. We can highlight those during those 3 days.
You're on.
Yeah,
all right.
Sounds good.
All right, thanks, guys.